to Fabric Monday. Today I'll talk about 5 secrets of parallel executions. Last week we saw an example of how to make parallel execution from notebooks. Today I'll talk about 5 secrets of these parallel executions. What are these 5 secrets? Difference between RunMultiple and pipelines, the full Lakehouse and attached code, dependencies between activities, notebook return value, and maximum number of activities. Let's understand these items one by one. First, difference between RunMultiple and pipelines. What do I mean about that? I mean that if I use a pipeline, I can execute a notebook. So I have an activity in a pipeline which can call a notebook, and I can use this activity from inside a loop. There is no problem. So what's the difference of orchestrating the notebooks from a pipeline or orchestrating the notebooks from inside the notebook? The point is, if I use a pipeline, each call creates a completely independent section. In this way, I'll be consuming a lot of resources. How many resources a session consumes? This is configured in the workspace settings. On your workspace settings, you have this configuration, the pool configuration. The default configuration is a starter pool, where the nodes have medium size and with a total of up to 10 nodes. These auto scales. What the size means? Let's see the node size. Medium. Medium means a node with 8 vCores. 8 vCores on the node, which is a virtual machine. So each session running a notebook can have up to 10 virtual machines with 8 vCores each. This means 80 vCores to run our notebook. And what about the resources we have available? This is the matrix of SKUs and the resource each SKU provides. One of the most famous SKU is the F64, because the F64 is also the SKU used for the trials. Every trial we have has an F64 size. And the number of vCores this SKU supports is 128. 128 vCores. So one session, one execution takes 80 and the capacity supports 128. Of course, will be limited. That's why sometimes you get a message, oh, there is not enough resource to execute your notebook. Yes, it makes sense. Of course, the resource consumption is way more complex than this, but let's consider this. What's important for us is the difference between the pipeline and the RunMultiple. And the difference between the pipeline and the RunMultiple is that on the pipeline, each notebook execution will trigger the creation of an isolated section, an isolated environment. So each notebook executed by the pipeline creates all this environment with this size that you just saw. On the other hand, the RunMultiple executes all the notebooks inside the same environment. All the execution is done inside the same environment. This saves a lot of resources. We can save a lot by using RunMultiple. Let's talk about the two. The full Lakehouse and attached code. What do I mean? Well, the notebooks can have a full Lakehouse. And attached code is something that I demonstrated in a previous video some time ago. We can put PY files attached to a notebook and call the code. Yes, we can. We can do all this. When we are executing multiple notebooks, we have one notebook calling other notebook. What happens with this configuration of the full Lakehouse and attached code? That's the point. The default Lakehouse and the attached code from the caller notebook is inherited by the called notebook. So the notebook which is calling the orders defines the environment. defines over which Lakehouse the other ones will be executing, and if they will use any specific library attached to that. Only the first one defines the environment. Let's see an example about this. Here I have a notebook. This is the same notebook which I used last week to illustrate parallel executions. So this notebook is calling other notebooks multiple times, many. And this notebook has a lakehouse, a default lakehouse attached to it. Which other notebook is being called? The other notebook being called has the name load orders. Load orders is the other notebook. Let's check the other notebook. Here is the load orders. There is no lakehouse attached to it. And these load orders is writing data to a table. Where would be this table if there is no lakehouse attached to the notebook? That's the point. The load orders inherit the default lakehouse from the caller. So the caller defines the default lakehouse, and all the other notebooks being called will use the default lakehouse defined by the caller. That's why the called notebook has no lakehouse linked to it. Let's get back to our slides. Dependencies between activities. What do I mean? On the previous video I showed how to run all activities, many activities in parallel. What if the activities depend one on another? What if they are not exactly the same activity? There is a dependence. One of them needs to be executed first and so on. For example, let's consider a complex sequence of dependence like this one, for example. Is it possible to express this dependence? Yes, it is. We saw that we need to build a DAG, a JSON structure, to express the activities which will be executed. In the DAG, we can include the parameter called dependencies and expressing the name of the activity. So one activity can depend from other activity. And when executing out the DAG, we have the option to use display DAG via graph views configuration. This option allows us exactly to retrieve this visual to see how the execution is working, especially in relation to dependencies between the executions. Let's see how this works. Here I have a notebook. This notebook is building a DAG. This time this DAG is built explicitly, and I'm establishing dependencies between the activities. So I have many configurations of dependencies between the activities in this notebook. Let's execute this notebook, and the notebook will be executed very fast. Let's see it. The execution is already on the last cell, executing the last cell in parallel but according to the dependence configuration, and I ask it to visualize graphically the dependence. Where is the graph? Let's wait this execution finish, and it will finish in a moment. Here it is. Once the execute finished, we have the graphical visualization of the dependencies, how the activities were executed depending one from another. So we have the dependencies graphically represented. Let's get back to our PowerPoint. Notebook return value. Yes, a notebook which we are calling, even if we are calling multiple execution in parallel, the notebook can return a value. How we get the return value from the notebook? To return the value, the notebook can use MS Spark util notebook exit. Activity results are joined in a single JSON. So if we are executing multiple notebooks, we'll get a single JSON with the result value of all the activities. Only simple data types are supported. Complex data types are not supported. Some data types will be converted to string to be sent as return values. So complex data types are not supported. The format of the JSON we get, this is the JSON resulting from the RunMultiple call. We get a JSON where we have properties with the name of each category, each activity, and in this property we have the return value, and any exception could also be included here. Let's see this working. Here we have our notebook. It's similar to the notebook with dependencies, which I executed just a few minutes ago. The difference is that now I'm receiving the return value and processing the return value. The notebook which I'm calling is returning one value. The value returned is the number of rows the data frame has. You can see I'm using the MS Spark Utils notebook exit and returning the count of rows. How will I read this value? I need to process that format of the JSON that I illustrated just a few minutes ago. We make a loop on the items of the result, getting the key and the value. And from inside the value, we need to get the property exit val, which is the return value from the notebook. So I'll be printing the category and the return value from each activity. Let's execute. It will complete the execution in a minute. That's it, the execution is completed, and the notebook first displays the result in JSON format, so we can see exactly the format that I illustrated in the PowerPoint, and then the result of the print with the loop, showing the name of each activity and the exit value, the returned value from each activity. So we can return values from the notebooks even when we run them in parallel. Back to our PowerPoint. What if I would like to return more complex values? What if I would like to return a data frame? That's more complex, but we can use temp views, for example. I already wrote an article about this. You can see here at the site that I wrote an article about how to use temp views to return values. We can create a temp view from a data frame and we can get the result back from the temp view. Then, the last but not least, the maximum number of activities. Take care about this. Microsoft recommends that you never run in parallel more than 50 activities. More than that, you can get unexpected results from your execution. Thank you very much for attending and see you next week.